Here we have the function, not the function, but the series ln of 1 plus 1 divided by 3 to the n, and we want to show that this series converges. So we want to use the direct comparison test. And so to use the direct comparison test, we have to come up with a series B sub n. And then we have to show two things. Series A sub n is less than or equal to series B sub n, and that the series B sub n converges. And we know that in general, ln of n is less than n. And so let's go ahead and let A sub n be ln of 1 plus 1 over 3 to the n. And then let B sub n be 1 over 3 to the n. And now we want to show that this is less than this. So that we can say that the series A sub n is less than or equal to B sub n. And so the corresponding continuous function of this right here is ln of 1 plus 1 over 3 to the x. And from calculus 1, the definition of the natural log is the integral from 1 to 1 plus 1 over 3 to the x. And then the function is 1 over t, and then dt. And so here we're dealing with n that is 1 or greater, and therefore the x will be greater than or equal to 1. And so we have ln of 1 plus 1 over 3 to the x, which is the integral of 1 over t, but since we're dealing with x greater than or equal to 1, and then 1 over t will be less than or equal to 1, since t can only take values 1 or greater. And so 1 divided by t will be less than 1. The antiderivative of 1 will be t, and then evaluating from 1 to 1 plus 1 over 3 to the x, then we get 1 plus 1 over 3 to the x minus the lower limit of integration, which is 1. So we get 1 over 3 to the x. And therefore we've shown that the ln of 1 plus 1 over 3 to the x is less than or equal to 1 over 3 to the x. And so the series A sub n is less than the series B sub n. And we have shown this part right here. And now we also need to show that the series B sub n converges before we can say that the series A sub n converges. So this is the same if we write this as 1/3 to the n. And this is a geometric series. With common ratio r equal to 1/3. And so it converges by geometric series test. Recall that the geometric series test says that if we have a geometric series, and if the common ratio is between -1 and 1, then the series converges. And therefore we have shown two things. We've shown that the series A sub n is less than or equal to the series B sub n. And we've also shown that the series B sub n converges. And therefore the original series right here converges by direct comparison test.